Good morning or good afternoon, depending on where you're at. My name is Atarot Azizi Namini, Director of the IBT slash ABCUTC, and very warm welcome to more than 700 sites that they have registered to listen to our July 2024 monthly webinar live. The title of our webinar today is Bridge Slide over the Gila River in Arizona. And we are delighted to have with us two engineers from the AECOM, Robert Ringwald and Christopher Labby, both with the AECOM. This webinar will finish no later than 15 minutes, 15 minutes after the hour. And during the registration process, we did receive a number of questions, but it is not late to submit some additional questions in case you have some. Just put on the dashboard. We're going to try to get to them as time permitted. If we don't get the time to address all the questions, we will post them on the website. Before we start our webinar, I would like to share with you some news related to the conference that's coming. First of all, the conference is sponsored by the US DOT through the IBT, ABC-UTC. The conference is also co-sponsored by Federal Highway Administration and 32 State Department of Transportation. Registration is open. So in order to help us, we will appreciate if you register early, also take advantage of the early bird registration rate. It's going to be expired soon. So registration is open. You can go to our website, register, and take advantage of the early bird registration rate. The conference program is complete. The conference is very rich. There is 9 keynote talks on Wednesday. Everybody is going to be in one room in auditorium. We're going to have just 9 keynote talk. Then on Thursday and Friday, there will be 5 parallel sessions. There will be 140 half an hour long technical presentations. This slide that you see over here, for example, there's a 27 presentation on ABC. There is a 8 presentation on artificial intelligence and digital twins. There's 7 presentation on bridge asset management system and so on. So there's also a workshop on Thursday. There's a free workshop on shotcrete using an ultra high performance concrete. So it's a very interesting shotcrete with ultra high performance concrete that has lots of applications to retrofit, upgrades, and so on. So the keynote speakers are really, we have lined up extremely interesting keynote talks. Michael Knott is going to talk about the ship collision. Dr. Shing is going to discuss all the innovations in bridge engineering that is going on in Far East and in South Korea. Eugene Burweiler is going to summarize some of the innovative concept that is going on in Europe. I will be giving a talk on the 3D printing with concrete. Mark Fensley, who is a graduate of the MIT, and he's gonna tell us about importance of the artificial intelligence and why the bridge engineers should know. Ben Grable, no introduction to Ben Grable, always has some very innovative concept that he's going to share with us. John Hillman is the head of the Kiewit construction company. He's a director of the Kiewit engineering group, and he's going to discuss the evolution of the contracting methods. Frank Jollinus is with the Federal Highway Administration he's going to give a talk on basically the substructure use. Danielle Whitlow, the bridge engineering from the US Army. There will be a reception on Wednesday. Please go ahead and reserve your hotel. It's a very busy time, December. There's opportunity to exhibit. There's also travel scholarship available. you can go to our site. And if you're a state employee, you can get a travel scholarship to come to the conference. So at this point, I'd like to turn it back to Patty Crow, who is really in charge of all the webinars for the IBT, ABC, UTC, to share with you some additional news related to bridge engineering. Patty, it's all yours.
Thank you, Torad. Welcome to this month's monthly webinar. As Torad mentioned, I'll go through a number of upcoming events, both for the IBT, ABC, UTC, and also from some of our industry partners. So to start with, we have an upcoming event with the Canadian Association for Earthquake Engineering and Seismology at Carleton University. They're putting on the 4th International Bridge Seismic Workshop. It's on August 11th through the 14th in Ottawa, Ontario, and the link included has more information and registration. The American Composite Manufacturers Association, the ACMA, puts on their annual Composites and Advanced Materials Expo, also known as the CAMEX. That will be September 9th through the 12th in San Diego, California. Registration and additional information can be found at the links below. The American Segmental Bridge Institute, ASBE, has their 36th annual convention and committee meetings from the 20th to the 23rd of October in Atlanta, Georgia. And now to the some additional IBT, ABC, UTC events that are upcoming. January 26th, we have our quarterly research seminar. The topic this month is, or this quarter, is a comprehensive decision support tool for ABC considering social equity. This is going to be a really great presentation. I really encourage definitely owners, but also consultants to attend this research seminar. The tool that they've come up with is loosely based on what Connecticut is already doing, but there's some additional components that I think really make the tool more robust. So this is going to be a great seminar. Please join us. Our next month's webinar is a general overview of vessel collision. And this will be by Michael Knott and Mike Winters, both with Moffitt and Nichols. This is definitely a topic that is high in everyone's mind right now. So that will be on August 15th from 1 to 2:15 Eastern. Please join us for that. Another thing to add to your calendars is our in-depth web training. This will be on September 10th from 11 to 3:15. The topic for this is innovations in ultra-high performance concrete. The idea behind the in-depth web training is it's much like these monthly webinars, but we have a longer period of time blocked out so we can really get into greater detail. The presenters that we have lined up are Dr. Aziz Namini, Ben Graybill, Eugene Breweiler, Sam Valaha, and Michael McDonough. The topics that we will be delving into are UHPC for shotcrete using UHPC, 3D printing utilizing UHPC, UHPC overlays for bridge deck rehabilitation, design examples, and then we'll get some updates on design, structural design specifications and guidance. So please do add that to your calendars. The registration for that will be opening very soon. And that brings us to today's monthly webinar. Our featured presentation is the bridge slide over the Gila River on State Road 79 in Arizona. This is a 1,416-foot span bridge slide. Our presenters are Robert Ringwald and Chris Labby, and they will be also taking questions after the presentation. So if you do have questions in the dashboard on the right, you can write those in during the presentation. And we welcome Robert and Chris. Thank you for joining us from AECOM today.
All right, thank you, Kathy. Okay. So this is for the SR-79 Gila River Bridge slide. It was a project done with ADOT and the Association with Federal Highway Association. Go ahead, Chris. Next slide. Okay, this is Chris and I. Go ahead. So this is our project team. Again, ADOT, FHWA. AECOM was the lead designer. I work for AECOM, so does Chris. I did want to mention Hugh Boyle out of Utah. Hugh is really helpful with the bridge slide. He's done a number of them, and he also helped with some of the guidelines for bridge slides, the FHWA guidelines. The construction was done by F&F Construction, and it was a CM at risk project, which is also a CMCG type project. Go ahead, next. Here's our design team. Next one. Okay. Here's our outline of the project, or of this presentation. We'll go over the purpose, project information, design, construction, some videos on the bridge slide, lessons learned, and successes. Okay, the location, it is in Arizona. The location is kind of southern Arizona. It's just north of the town of Florence. And this is a critical road. It's kind of a bypass if anything happens on I-10, which is a major connector between Phoenix and Tucson. So this is a bypass. It does get a lot of traffic. Go ahead. So the need for it was the superstructure was in deteriorating condition. The deck was in bad shape. We also had these pin hangers details which were fracture critical. So it was decided to replace the bridge. Next. So it was complete replacement. The existing bridge was a 30-span bridge. And really our focus was to minimize impacts to regional traffic because this is a highly used corridor. Next one. So this is the existing bridge, 30 spans. There was several different bridges built. I think the first one that wasn't showing up here was even in the late 1800s. It used to be a old wagon trail. They built a bridge halfway across, or half the length of this bridge, and then after some flooding, they extended the bridge, made it twice as long after they had flood issues. So you can see all these existing piles and foundations. Next one. So here's the cross section. This is the existing bridge. And then the new bridge, we're widening out the shoulders. We're also providing a sidewalk on one side. There is a bar to the north of it, and people go back and forth. So we want to make sure they're safe. Next one. All right, so we did follow a NEPA process. The utilities were a major issue. We had utilities both sides of the bridge, and we had to get them out of the way. Right away, we acquired right away. We even required like a utility corridor on the east side of the bridge. Construction was funded in 2020, and it was almost 14 million. FHWA, because it was everyday counts, and I'll get into that, but there was like 8 everyday count initiatives. We were able to increase the funding by 5%. And then the contract time was around 18 months. Next. Okay, so big deal. This is the existing volumes on here, 12,000 vehicles per day. ADOT did do a bridge rehab where they had, or a deck rehab on this, and they cut it down to a single lane and kind of phased it, and the traffic really blew up. So there wasn't an opportunity to try to really phase that construction very well. Go ahead. So the shortest detour to keep it on state routes is about 100 miles. There was a local detour that was possible, but it would require a bunch of upgrades that were very costly. Okay, next one. So we did, F&F Construction was selected. They were the contractor manager at risk. And the project team developed a slide solution for this, where we could build the bridge off. We could build the slide portion off to each side of the bridge, come in, demo the existing bridge, build the approaches while traffic was maintained on the slide portion, and then slide it in place over 2 weekends. We did have, like I said, enhanced pedestrian and better life cycle, and we also there was a lot of scour. This bridge was a scour sensitive bridge, so we eliminated the scour issues with the new foundations. Go next one. So contract manager at risk, CMAR, also known as CMCG, depending on where you're at. The way that works is you do have the owner, which was ADOT, or the design engineer reports directly to ADOT. We also have the contractor, which reports, they're selected based on qualifications. We always recommend them being selected early because it allows us to get in good input. And then there's an independent reviewer that's basically like does an independent cost estimate just to make sure that they look at the cost estimates, and so that way we make sure that all the bid or the cost of the project, the contractor's price is fair, and that works out pretty well. So next slide. Oh, so the existing bridge, you can see there's numerous bridges that were built, a lot of existing foundations that we had to miss with this new bridge. Next one. So here's kind of a video that shows a little bit. Now, we did have a utility corridor. We had power lines that were in the way. We moved the power lines out of the way so that they could erect the girders, do the drilled shafts, place drilled shaft reinforcing. And then there's the existing foundation, so you can see what we had to miss. Okay, and then what we did is we did build our bents underneath the existing bridge on drilled shafts, and the drilled shafts were placed on the outside of the existing bridge so they could get them in. And that helped too, is helped us avoid some of those existing foundations. Next slide. Okay, so utility relocate, that was a major thing with schedule, trying to get all the utilities relocated and right away cleared for that. Next one.
Thanks, Rob. So as we just previously mentioned, we were going to construct a bridge to provide shoulder and sidewalk enhancements. So when we considered the development of the bridge slide, the proposed bridge was 14 spans overall, with spans arranged at 101 feet on center with 99-foot 5-inch end spans. And that was done to actually line up with existing pile foundations that would not be in conflict with the shafts. So the span arrangement actually worked out fairly nicely. So in order to accomplish the actual bridge slide itself, we, as Rob mentioned, we constructed drilled shafts and columns on either side of the existing bridge and built the pier caps beneath the existing bridge superstructure. We used the 58-inch bulb T precast concrete girders, 3 girders on each side. And what this allowed us to do was to build each half of the bridge on either side of the existing bridge, which allowed the existing bridge to remain in service while all of the stuff could be built on either side. And once the decks were poured and the diaphragms and slide shoes were completed, we were able to shift traffic to the new portions of the bridge, each half on either side, using temporary concrete barriers. And this allowed us to demo and remove the existing bridge between the 2 bridge halves. Once we were ready to actually do the bridge slide, each bridge slide was accomplished during a single weekend. Traffic was shifted to the other side, and with flaggers in order to permit one-way traffic movements across the bridge while the bridge slide was taking place. Then we would resume the 2-way traffic and prepare for the next bridge slide. And then we did the same thing on the other side, using the slide jacking block and the PT rod, which we'll show you in a second. And then in the final phase, we still have the temporary concrete barriers, and we had sufficient room to do a 6-foot closure pour between the two temporary exterior girders, which would become interior girders. And that width of a closure pour allowed us to lap in the reinforcement steel as well as provide a closure between those two deck edges to smooth out the overall transition. And during that time, expansion joints were placed at the end of each frame. Picture is worth 1,000 words, but video really helps to illustrate how this actually takes place in practice, especially with a bridge that's 1,416 feet long. So you can see that the construction access roads were built to accommodate construction vehicles. The drilled shafts and the piers, as well as the girders, were erected on both sides of the existing bridge. Traffic was then shifted to the outside so that the existing bridge could be demoed in between. And then
hey, Chris, and this did allow us to build we built the abutment in front of the existing abutment and allowed us to build the approaches.
Correct.
During the demo phase.
With a very similar kind of detailing, except for a back wall. Now, when the bridge slide was taking place, it was a series of 4 3-span frames and 1 2-span frame. So each unit that was continuous was slid in unison for those various continuous units. Then the closure pour was placed, and then everything else was finalized, and the existing pier cap, or the new pier cap, I should say, the superfluous edges were removed. We'll get into that shortly. So there are several different methods of sliding bridges. We opted to use PT rods with Teflon pads. It gave us the ability to limit snapback, improve jacking efficiency, and with end blocks that were providing the ability to back up the slide. The slide shoes that you can see on the bottom left allowed us to use a series of Teflon pads that would allow the girder to walk, allow the bridge to walk across as it slid, and they were tapered, which allowed for better transition of the slide shoe onto the Teflon pad, so it could gradually transition into the Teflon pad as pads were removed and advanced as the jack was taking place. It also allowed us to jack the shoes vertically for final bearing placement. Now, these are the elements of the actual slide. So first of all, we have the jacking block, and that is designed to take the full load of the jacking force for sliding. Then this is the actual hydraulic jack itself using Dewey deck. Then there's the PT bar itself. This was the manifold that was used to control all the jacks. And by doing so, they were able to monitor the advancement of each pier diaphragm to make sure that they were advancing in unison, and they could control the hydraulic jacks independently if for whatever reason one end was advancing a little bit further than another. These are the sliding shoes that were mentioned. They're slightly tapered to allow for easier transition across the sliding pads. The threaded bar was designed with 20% of the dead load and the construction live load for static friction, and 15% of the dead load plus the construction live load for kinetic friction. We used a 2¼ inch diameter grade 150 PT bar, and the sliding pads consisted of 3 12-inch by 14-inch by 2-inch Teflon coated bearing pads. One of the complications that we ran into with the slide, this is a typical fixed and expansion restrainer detail, and this is usually cast into the pier cap to be eventually closed in with the pier diaphragm. However, we could not actually cast this into the pier cap without the slide actually interfering with the restrainer locations. So we had to come up with a means of actually incorporating that into the pier cap and at the same time allowing for the bridge slide to take place. The solution that we arrived at was to place a steel tube insert that allowed the contractor to tuck in the assembly into the pier cap itself so that the bridge could slide across the top of it, and then the cables could be pulled out and then the restrainer assembly could be completed at that time. So as part of the bridge slide design, all the bridge caps, pier caps had to also be designed with the new bridge on either side prior to the slide. And then there's a phase where you've got half of your bridge slid into place, and then you've got the phase where the remainder of your bridge is slid into place with a closure pour. So you're looking at essentially several design conditions to look at to make sure that you've got sufficient flexure as well as stirrup steel in there to accommodate whatever loading condition might be taking place during the individual phases. Upon completion of the bridge slide, excess pier cap material was removed. Part of it was to mitigate any excessive dead load that would result in undesirable PT effects. But also there was a concern on the sidewalk side that somebody may hop a barrier and decide to walk along the pier cap, and that was a safety issue that we were definitely concerned about. So one of the things that we detailed for that pier cap removal was the means of providing a clean looking pier cap at the end where the reinforcement would be tied in on either side to make it look like a clean finished pier cap at both ends. It also helped to mitigate the hydraulic impact. With that, I'll turn this back over to Rob to talk about the construction.
So this is under construction now. This Arizona, a lot of our rivers get, they don't flow all the time. So we did have a little bit of flow down in the Gila, but when we get monsoons and other things, they could become raging, and they get quite a bit of scour. So one of the issues was that we had to account for scour. There was some mining upstream, or potential mining, aggregate mining. So the scour depth had to be designed around 45 feet. So very critical for the bridge. You can see here, this picture is where the power lines that you see, those were relocated along a utility corridor, get them out of the way, and this is them setting the reinforcing for the drilled shafts. Go ahead, next slide. So this is them building it. The pier caps, it was kind of a shallow foundation there, but again, you know, we can get up to 45 feet of scour. You can see where we're building the bent cap underneath the existing bridge, so we can keep the traffic open. Next slide. There's another one where they set the girders, set the overhang formwork. Next slide. So now at this location, during this phase, we were able to build, like we said, we were able to build the approaches because the abutments were set in front of the existing abutments. Then we built the approaches for the next phase, and we were able to demo out the existing bridge while traffic was on both sides. Okay, next one. Okay, this shows that center block with the PT rod. On other bridges, we put a block on both sides so we can reverse it. On this one, we work with the contractor. Given that we weren't sliding very far, we didn't have a whole lot of elongation of the rod. We just went with a single block in the middle. Okay, next slide. So we were out there the whole time during the slide process. We had engineers on site, myself. One of the frames, it took them approximately about 8 hours to slide one frame. So they were sliding 2 frames at a time. The weekend closure was about 10 o'clock on Friday night to, they had to have it open, I believe, 5 o'clock on Monday morning for traffic. And during that time, the traffic was one lane on the other side with the stoplight. And so that during those times, we didn't get too much, a little bit of a backup, but not too much. But the bridge was able to be slid within that time frame. If they were really pushing it and try to be a little bit more efficient, I think they could even be less. Like I said, about 8 hours per slide per frame. Okay, go ahead. Okay, another picture during the slide. They monitor, like Chris said, they do monitor the slide so that we're trying to keep it, less than a ½ inch or difference between each of the diaphragms. They constantly are measuring that to make sure that it's being slid at the same rate. We also don't want to get it, if we get it too advanced on one of the ends or something, you can get it out of, skewed a little bit and out of alignment. We did have in between each of the frames, we did have like a 3-inch joint, expansion joint. So there was a little bit of gap in between each one. This shows, when we get a flood in Arizona, or we did get some monsoon weather in January, and we did get the river was flowing pretty good. And luckily it came down a little bit so we could finish we could complete the slide the following weekend. We didn't have to delay anything. Next one. So again, here's the bridge slide. Go ahead. So this is during the bridge slide. So this is a video. So you can see we have all the jacks. We have them connected. All the hydraulics is connected, so they can make sure that everything's moving at the same rate. With with the deck on it, we had a very stiff diaphragm. So we really didn't see any deflections or anything from a lateral standpoint. It was just more of trying to keep those moving at the same rate so we didn't get a twist or something out of alignment.
Yep.
And then over the expansion joints, after they did that, we just put metal plates over the expansion joints so that they could, traffic could, you can see the metal plate sitting there. But here's one of the slide, actually. This is advanced. When you're looking at these slides, you're out there, it's kind of like watching paint dry. I mean, they move pretty slow, but so this is where they're sliding one of the last frames in place. And then you can see where we're going to have our closure pour. Now, we had, I think, about a 6-foot closure pour. We try to make those closure pours as large as possible because you do have a little bit of difference in camber and stuff between the 2 bridge phases. So we want to give it as much tolerance so you have rideability there. So
okay.
Are you playing the video, Chris?
Yeah, this is going to be a video that ADOT, well, I'm sorry, my apologies. This is actually drone footage of the actual completed bridge where you can see the individual elements. There's the abutment that Rob had mentioned.
Right, and so at the abutments, we had wing walls to hold back and part of the slide, and we just left those in place. Those acted like the wing walls, so that saved. F&F was a contractor, really good contractor to work with the CMAR process. That really works well because we have their input. They starting at after the 30% or during the 30% non. You can see the chair.
And I think one of the nice things about having CMAR on early is that a lot of the questions that could potentially have led to delays later on, all those questions were answered. So if there was any need for any modifications, we could get that worked out up front so then it doesn't become a field issue. It gets incorporated into the design plans before construction actually starts.
Right.
So the next video is something that ADOT put together for public relations to let everybody know what was going on with the project and how everything was advanced.
Connecting Arizona. This is a key corridor. The nearest alternate route is more than 100 miles away. Closed State Route 79 for about 6 months. This is a 2 weekends process, but we opted to look at the bridge slide to be able to maintain traffic for the entirety of the construction.
We built the bridges on the outside of the existing, and we already demoed the center.
Right now, we have traffic on the southbound new bridge as we move the existing northbound bridge over into place. This following weekend, we will shift traffic to the new northbound bridge as we slide the new southbound section into place. It's using what I'll call a big screw. All the pressure is on the far plate. It uses that to pull it over.
So you like more 2-inch mats on the bottom. We use hydraulic jacks to push it in, and they actually use down slope to keep it moving. Just helps it go a lot smoother through the safer in the environment as well. Correct. Takes oil off the baby deck. So
this is a 2-lane bridge that has reached the end of its life expectancy.
So the 2 12-foot lanes, no shoulder at all. The new bridge is going to have 2 12-foot lanes, but 2 8-foot shoulders on each side as well. And we're also adding a 6-foot pedestrian walkway on the west side of the bridge.
We're going to be able to increase the ability of heavy loads. There's a couple of unique challenges. The first is the fact that we're trying to reconstruct the bridge over the Gila River. We have monsoons that we have to contend with.
We're enforcing a lot of these abutments. We're putting gabion baskets in there, and it goes probably about 40 feet down. We don't watch out the abutments. So I think everybody's excited to see this new bridge come along, and yeah, we've had nothing but good things about this project.
We do want to thank the public for patience in this process. We've tried to do as little disruption as possible to the flow of traffic. It's our idea to stay out of everybody's way so the traffic keeps moving.
All right, so this project, I did want to mention this project included a bunch of FHWA everyday account initiatives. Some of the initiatives included accelerated bridge construction for the bridge slide. It did the contract manager at risk, CMAR, also known as CMCG. We did do 2D hydraulics. The contractor, we created a 3D model of the project, and then they did the 4D and 5D modeling. So the 4D is captures the 3D model on the progression of construction, and the 5D captures the cost as you progress in construction. We also used ADOT has a drone LiDAR, so they did do some mapping to help support the design. And then I did include down at the other day, which was very helpful, the everyday counts, federal highways. Very helpful link. They always have some good innovation, good ideas, and the links down below. Okay, next one. Okay, so the project cost, we get a lot of questions on this. This is in 2020 dollars. So, when people think about CMCG, contractors selected based on qualifications, do they really get a good cost for a project? And with the ice, I think we really get a good cost. We can get into that. But this total bridge cost, it was under $200 a square foot. And that includes all we built a spur dike on the south side. We did do roadway improvements and the approach work, all that, we're still a very competitive cost. The extra cost of the bridge slide you know, because we were eliminating, when we looked at different alternatives, one of the alternatives included a local detour, and to try to improve that detour, which would have improved some of the intersections, pavement, and all these other things. The cost of the bridge slide was the most economical alternative. And on the north side of the project, we were restrained by a canal that was owned by the St. Carlos Irrigation District. So it is, it's part of an Indian community facility, which we had to go through BIA and everything else just to go over that canal. So we were pretty well constrained. We did look at alternatives to try to build it offline, but that really didn't pan out. This was the most cost effective. Okay. And then the offline construction, we were able to build it offline, so everything kept traffic going except for those 2 weekends. And having the contractor on board, we were able to tailor the design to their best means and methods, which helps reduce costs. So they had ideas on how they want to construct it. All the contractors I've worked with, I've done a lot of CMAR and design builds. They all have different ways. They have different false work and different things available to them that can save cost. And, you know, when you do a typical design bid build, then they're always looking at maybe changes to traffic or other things, but having them on board through the process helps us tailor that to their best means and methods. And I think that helps reduce the cost, and it also helps reduce the risk because we have them on board. So there's, you know, they understand everything about the drawings. Really reduces claims. We only had a couple little extras that were change orders that were real minor, and they were just from things unanticipated. Again, that's allowed that use of extra 5% of funding, of FHWA funding for the project, which helped out. Next one. So lessons learned, building those big pier caps underneath the existing bridge. When we did have the CMAR process, we talked through it. We had a couple, they had some ideas on how to keep some of the levelness that wasn't necessarily followed through. So there was a little bit that they had to resurface by grinding and placing some, a little bit of overlay and stuff just to make sure that they met our tolerances. So we put in construction tolerances. That way, if something's a little bit out of level, when we did our design, we checked that bridge and was designed for things to be a little out of level, you know, minimally out of level, I say, but that it could accommodate that. I think when we were jacking it, we did look at, you know, the contractor was able to keep the frames well within a 1/4 inch, but we did allow for some, you know, a little bit of deflection between the diaphragms, but it was so stiff that we didn't even see any of that. We did not see any kind of cracking or anything else of any of the bridge. The deck or the diaphragms went real well. So one of our recommendations that came from a meeting afterward was, with the CMAR, you do have part of the construction team is in the pre-construction, but not all that team is out there during construction. So we just want to make sure, you know, one of the recommendations is to really flag what's important to the people that are going to be constructing it, so that way we get a good, from going from design and going from the pre-construction to construction, that the ideas, the risks, those type of things are followed through. The contractor having CM at risk, they were able to identify the construction risk, you know, with flows, the other things like that, and include that in the project so we can monitor those risks. Okay, go ahead. So success, boy, this was very successful. The public was very happy with this, being able to keep it open. Went real well with the public. We received a lot of positive feedback. We eliminated that 100-mile detour to try to keep it on a state route. We were able to maintain the traffic with only those two weekend restrictions, and those restrictions maintained traffic, one lane of traffic with a stoplight, and then the stoplight would go to the other direction. So it was really minimal disturbance to traffic. So as with all these everyday count projects where we were able to do this, it increases the industry knowledge, increases the knowledge of contractors. There's a lot of contractors looking at this, other contractors, other engineers, just helps with our database. And then we can see what does it cost, so that it does reduce their risk and people are more willing to use these innovations. Excellent. Okay, so as I stated, project was a great success for ADOT and stakeholders, and we received a ton of positive feedback from the community, from the county, Pinal County, from the city of Florence, or town of Florence, all positive. Okay. All right, thanks everybody.
All right, thank you for a very interesting project and the presentation. At this point, we're going to turn it to Mr. Jamo from the Federal Highway Administration to moderate the question and answering period. Jamo, it's all yours.
Thank you, Atarad. Can you hear me?
Yes, we can.
Yes.
Oh,
Yes.
Great. Chris or Robert, a great presentation. This is one of the unique structures that have multi-span slide of a bridge. Usually they are span by span slid, and this is a nice project to see the bridge divided into units and slid in 3-span, multi-span slide. That's a great project. We have a few questions here. Pre-webinar, a question that came in, and then we have also some questions that came in during the presentation. So we'll start with the questions that came in pre-webinar. And the first question, it has to do, you mentioned in your presentation about deflection tolerance. And they say, were there any lateral slide deflection tolerances during the move?
Yeah, I think we had, I can't remember the exact number, but we had about a ½ inch that we looked at. You had that real stiff diaphragm with the deck, but they were with that stiff diaphragm, with the way we were controlling it, we really didn't see much. Maybe it would be certainly less than ¼ inch. And when we're sliding it, we're measuring and making sure it's sliding along. It's more to get it, to make sure it doesn't get out of alignment.
Mm-hmm. Mm-hmm.
Yeah, and one of the things that's key too is that you have contractor personnel at each of the pier diaphragms, and they're constantly monitoring the movement, and they're all communicating with walkie-talkies, and they're able to communicate with the individual who's responsible for controlling the manifold. So for some reason they observe movement that's going a little bit faster than, say, another pier diaphragm. They have the ability to communicate that and be able to control the hydraulics in order to limit that movement from happening.
That's great. This is a follow-up question about the monitoring. You mentioned that you have surveyors on the deck taking the progress, monitoring the progress of the slide to avoid stresses and differential deflection. Could you want to add to that?
Yeah, so it's almost like they put a tape out, right? They put a scale out on each of the pier caps, and then they're watching that. They have marks on the diaphragms, and so they can watch that as it moves, and they can make sure that they're moving at the same rate.
To synchronize the move along all piers at the same time. Okay, and you have and then you have the manifold to monitor the movement of the piers as well.
Yeah, that helps us adjust. So if something looks like we're getting out of alignment, again, with that diaphragm, we really didn't have any kind of differential part of it. It was more of just keeping it in alignment so it didn't get skewed or something and out of alignment. But with the manifold, it allows them to increase and decrease pressures that are on the jack so that it can be uniform.
That's great. That's great. Now, have you observed any cracks in the deck after completion of the slide?
No, we didn't. We did not observe any kind of cracking on the deck. We did not observe any kind of cracking in girders or diaphragms or anything else. We were out there monitoring that. Everything went well.
Great. There's a question about contingencies. Did you have any contingencies in the planning phase to manage risks? For example, during demolition, complication, let's say labor fatigue, unforeseen conditions. Did you have to have contingencies in the plan?
Well, certainly there's a lot of risk with projects and even a slide project. There's other risks. So what was great about this is that it was a construction manager at risk. So we had the contractor on board to help manage those construction risks. And then they put contingency in certain things. So it also helped ADOT, okay, they could evaluate with the contractor and negotiate some of those risks. So, maybe the contractor, if it was a design bid build, they might put a bucket of money for that risk. And if that risk doesn't come true, then they capture that as profit. Whereas if they share it with the agency, then the agency may pay a little bit more for the risk if it occurs or not have that risk. And we really didn't see anything. There was a risk of flooding. There's some other risks. Some of the utilities were a little bit late on getting moved, but nothing major happened. Yeah.
Great. Now, did you have to grind the deck or put overlay to offset, let's say, any discrepancies?
So when we did do the closure pour, because you do have different timing and you have different creep and shrink and, these precast girders and stuff. So they do get a little off. That's why we try to make the closure pour as large as possible so that if there is a little bit of, if the girders a little bit are at mid-span a little higher or lower than what we predicted, we have a little bit more tolerance. And so the contractor, we did place the closure pour. There was a couple areas that were a little bit rough and they did grind a little bit on the closure pour. And but other than that, there was no other grinding.
No overlay.
And no overlay, no.
Okay. There's a question about the approach slab, where the approach slab cast in place or precast, and was it moved with the end spans or casted after?
So we were fortunate here because we could build one side on the north side. There was some bank protection, but it was far enough away from the existing abutment. We were able to place the new abutment in front of the existing abutment, and we did the same on the south side. So we could build that whole abutment offline in front. And then during the phase where we had the traffic on the slide portion of it, it gave us enough room to come in and construct the approaches at the bridge. So we constructed those just conventionally during the phase where we were removing the deck. And so when we slid it in place, we didn't, it slid in place, open to traffic.
Okay, that's good. There is a question about the bearings under the bridges in phase one, and that's the temporary support. Did you use bearings to do that to support the phase one construction, or you use a Teflon?
I think they placed the Teflon. Do you remember, Chris?
Yeah, so I think they placed the, yeah. They did, and they also had additional bearings on hand. And so what that allowed them to do, as the slide shoe was advancing, they would put another bearing down as it was progressing across the bridge, and then the previous bearing, once the slide shoe was off that bearing, could actually be removed, and then they could just keep leapfrogging with the bearings. And I believe at some locations, I don't recall off the top of my head, but I think there was an opportunity to potentially use some of those as final bearings at select locations.
Well, at that, where we had the pin pairs, okay, where we were pinning them in the flat condition, we allowed the slide Teflon barriers to be left in place, and then they did their pores and everything to lock it in with the pin connection. At the expansion ones, after the bridge slide, we jacked up the bridge and removed and replaced those with Teflon pads at the expansion joints.
Okay.
Right.
All right. The last question here I have is about the joints. You mentioned in the longitudinal direction, you have 6 foot closure pore, but how about the transverse direction? What did you have?
Yeah, so we had like a 3-inch joint, okay, during the slide, and then we put in expansion joints after the slide. So when we put traffic on it, we put a plate over the top of it. When they slid it over, once it was slid into place, they did do like a little nighttime closure to place those expansion joints in place. And then it was covered with a cover plate during the temporary condition.
That's great. And now we're going to go over the question that came in during the presentation, and I'll forward it to Yogesh to go over the questions came in during the presentation. Yogesh?
Okay, thank you, Jamal. I'll ask the questions that came during your presentation. The first question is, was consideration given to reusing the existing pile foundations for the new bridge?
Yeah, we looked at it, but there again, this bridge, they had a scour slab, and it was Arizona. A lot of the bridges that were designed, post 80s, are very scour vulnerable, and so that was one of the main issues. We get about 45 feet of scour. Certainly those existing foundations would be problematic. So part of the bridge had a scour slab on it just to try to prevent that. And again, the existing bridge was at like 50-foot spans, right, Chris? Is that right?
Yeah.
So anyway, it was decided that because of the scour issues with the existing bridge, because the scour was not all the way across, or the protection wasn't across the entire bridge, we decided to remove it. So
okay, all right. As a follow-up to that question, did you leave the existing piles in place, or did you pull them out?
So the existing foundation was removed up to the top of the piles. So the pile caps were removed. The steel piles were left in place.
Okay.
And they were accounted for in our scour analysis.
Okay, thank you. Next question. Did the median pour consider the effect of vibrations on wet concrete during the setting process due to traffic adjacent to it?
We've done a lot of closure pours like that. Typically, we allow traffic on the bridge, and we don't consider the vibration. We haven't seen that being an issue with the precast girders. We don't see a lot of vibration. I know if you have a real long steel span, you get a little bit more vibration, but we really haven't seen that as being an issue. So traffic was allowed on it while they did the closure pour.
Okay, thank you. Next question, it's saying, looks like you proposed beams lower than the existing ones, and thereby you reduced the hydraulic opening. Can you comment on that?
Yeah, so we went from, our spans were longer. We eliminated a lot of piers in the river, so we're actually improved the hydraulic condition. And especially, during a scour event, when you scour out those piers and you have a flow in the 100-year or the 500-year event. So actually the overall opening during that would be more, so we were able to have a slightly lower bottom chord and still keep freeboard and meet the requirements. Now with the 500-year, it would hit the bridge, but 100-year, we were able to meet the requirements. So we did have to design for water hitting the bridge at 500-year. And the existing bridge was real flat. Didn't have a profile. Ours did have a profile, so it did help, with that issue. Go ahead.
Okay, thank you. Next question. Why wasn't the bridge just constructed without the sliding, either by leaving the two lanes as independent bridges or simply building a second set of lanes without the exterior ones?
So we looked at different options. We looked at trying to realign it. Again, that north canal was a restraint. We did have some properties up on the north side that they didn't want to impact, especially the north that canal to the north. So we did look at options. Again, it was decided to go with the slide, that would be a better option than trying to realign it, get all the other different right-of-way, all the impacts to right-of-way. And then two is when we penciled it out, the slide was really cost effective. Again, we were like $200 a square foot, very cost effective bridge overall.
All right, thank you. Next question, did the contract documents place any temperature restrictions on the slide windows? It looks like the slides occurred both during the day and during the night. We
didn't have any temperature restrictions on it. The joints have temperature restrictions. We call out a joint, but they adjust it to accommodate temperature. But other than that, no temperature restrictions.
Okay. Next question, are the bearings in their final location supported by pedestals which are poured after the slide?
No, so the way it was supported, yeah, I can't remember, Chris. I think we did at the pin connections we did. So we did add, we left the one bearings in place. Under the diaphragm, we wanted 2 points of connection during the slide. So we try to keep it to 2 points. That way you don't get like a three-legged stool. We can count on what those pressures are a little bit better. So when we were sliding it, the bearings were off of the diaphragms. And then when we slid it into place, I do believe we did. We'll have to look at that, but I think we did do a pedestal. But we did adjust the ones on the expansion ends and added a pedestal and bearings at those locations.
Okay, thank you. Next question. What was the material used for the closure pour?
Just regular concrete. It was just regular deck concrete. I think it was 5,000.
Okay.
Yeah, same as the deck. And there was enough room in there for us to put traffic and push them off to the edges because of the sidewalk and the increase in shoulder width of the new bridge to where we could just build that conventionally.
Okay. Next question, were there any PTFE bearings placed beneath the concrete girders during the sliding process?
We've used the Teflon bearing. Yeah, go ahead.
Well, we used the slide shoes, but not under the girders themselves, no.
Yeah.
Only for the diaphragms then?
Yeah, just the diaphragms. Again, we wanted to keep it 2 points, 2-point connection. That way we could better predict that loading.
Okay. Were there intermediate diaphragms included in the design?
Yes. Concrete, ADOT standard is to use concrete intermediate diaphragms, which again help with the rigidity of, if you're looking at laterally. So.
Okay. Thank you. Next question, did you remove both ends of the pier caps at the end of the construction?
Both ends, yes. Yeah, and we get that question, you know, was it considered, you know, for future widening? There was no plans for future widening. There's no funding or anything else for future widening. So the additional, they wanted to take off the additional weight for the final condition. Plus, ADOT felt like it was kind of a safety concern to have people get out there on those bins. So we removed them, and then like Chris had in his details, we did come up with a detail where they could be the end caps. We could provide a nice smooth finish at those locations.
Okay, thank you. Next question, was pre-stressing used only for the concrete girders or was it used for any other bridge element as well?
Just for the
just
girders.
precast. Yeah, just girders.
Okay.
Yep.
All right, thank you.
One thing I do like to mention is, you know, when we design the rods and stuff like that, the 20% is conservative, but it's cheap insurance. If something goes, you know, if you have a problem jacking it and all that, it's more than enough. Those rods are pretty inexpensive. It's good to be a little bit conservative on that, so you make sure you don't have any issues. Go ahead.
Okay. All right, thank you. Next question, did Arizona DOT ever consider leaving the ends of the pier caps to allow for future bridge widening?
It was considered, like I said, they wanted to remove them. They wanted to remove that load. They did not want us to design the shafts for additional live load and dead load. And then that was also a safety issue.
Okay, next question, it's coming up similar to something I may have asked earlier, but it's asking why not build the bridge to the side of the existing one and not do the slide?
It was evaluated, like I said. I think the slide is only like, we did another slide with this contractor up in Flagstaff where we slid 2 separate bridges. And so the contractor was well aware of how, you know, the cost and the constructability associated with the slide, and they felt very comfortable with it. So I don't think we really had a premium of cost. I hear sometimes people say 20%. I think this one was more like 5% of the overall construction to do the slide, and it was offset by the maintenance of traffic. So doing the slide really wasn't a big deal. The only throwaway was that end piers.
Okay, next question. It's got a few pieces to it, so I'll ask them separately. It's asking what was the deciding factor in splitting the deck down the middle and sliding it in 2 pieces rather than building it all off to one side and sliding it over as one piece? Was it a right-of-way issue, utilities, substructure cost, or something else?
So we did look at that option, and when we did our PA, we were a little bit worried about the contractor's ability to remove the bridge, you know, in between the 2 different sections. So originally we were looking at building most of the bridge off to one side, sliding it over, opening up to 2 lanes, and then just doing a small widening. So that was considered. This one worked out real well. The contractor wasn't concerned. They were able to shore up, you know, those pin connections, some other things that we thought might be a difficulty, and build it off to both sides, which kind of helped balance the piers. So it was kind of a benefit to split it in half, balance it, and I think it saved cost. If we were trying to build it all on one side, then we would need more structure on one substructure. We were able to build it off of the drilled shafts that we had for the final condition. ADOT's tried to build stuff on false work in the river. They had one bridge that was built on false work, and then we do get monsoons and we do get flooding. And when we get flooding, that on one bridge, it washed out all the false work, and it was a huge cost to ADOT to repair the bridge that was partially constructed. So it gave us that opportunity to better balance it and use the final foundations. Yeah.
Okay. One question came up regarding the existing gas line during construction. How was that handled?
So we So we removed most of the utilities in the existing gas line that was there. They were supposed to remove it and put it over in this utility corridor, although they ran late now, so they were able to bypass that, so that was abandoned. So we didn't have to worry about it.
Okay. And one final question, which came in before the webinar, was ADOT pleased to a point where they would consider CMGC again for future projects?
You know, CMCG, I did my first one for Maricopa County back in 2003. It's readily used in Arizona. A lot of the agencies, including ADOT, they really like that for certain projects. I can, you know, given the value on this one, given the bid that they received and everything, I think it's super. It can be competitive, and there's so many advantages of not risking having claims during construction that absolutely they like to use that method.
Okay. Well, Chris and Robert, I thank you for your responses. That completes the questions that I wanted to ask. I'll turn it back to Adirad.
Oh, thank you.
All right. Thank you. Thank you, Jugesh. Thank you, Jamal, for moderating. Thank you. Thanks to our speakers. Wonderful presentation. On that note, we're going to conclude our webinar and hope to have you back with us for our next month webinar. Thank you and so long.